Newton's law of motion. Changing the state of motion by changing speed, direction of motion, or both. Newton's first law. If an object maintains its state of rest or uniform motion in a straight line until and unless an unbalanced force acts on it, if force is equals to 0, then initial velocity is equals to final velocity. Inertia. The tendency of a body to resist the change in state of rest or motion is called inertia. Inertia of rest. The tendency of a body to resist the change in state of rest by an external force if initial velocity is equals to 0, hence final velocity is also equal to 0. Example is dusting mat, shaking of branches. Inertia of motion. The tendency of a body to resist the change in state of motion when the object is in motion. Initial speed is equals to final speed. Example, moving pan or moving top. Inertia of direction. The tendency of a body to resist the change in state of direction when the object is in motion. Initial direction is equals to final direction. Example, person turns when bus turns. Mass and inertia. Mass is a measure of inertia. The greater the mass, the greater is the inertia of the body, and vice versa. Momentum. P is equals to m into v. It is a vector quantity. It has both magnitude and direction. SI unit is kg meter per second. Newton's second law of motion. The rate of change of momentum of a body is directly proportional to the external force applied to the body. Force is directly proportional to change in momentum by time. F is equals to m into a. Change in momentum. Final momentum is equals to mass into velocity. Initial momentum is equals to mass into initial velocity. Change in momentum. Delta P is equals to final momentum minus initial momentum. Delta P is equals to m into v minus m into u. Therefore, delta P is equals to m into v minus u. Impulse. Impulse is equals to change in momentum. Impulse is equal to delta P. Impulse is equals to force into time. Third law of motion. Whenever one object exerts a force on another object, the second object instantaneously exerts an equal and opposite force on the first. For every action, there is an equal and opposite reaction. Examples are, when the bullet is fired, bullet moves forward, gun moves backward. One more example is, when a boy pushes the boat backward and the boat pushes the boy forward. This is the action and reaction examples.